Hi, I'm David.
I'm Josh.
I'm Sean.
And we are Team Sandstorm.
We're here to talk to you about Rhythm Stomper. Now for the project overview. Rhythm Stomper, much like other rhythm-based games available on the market, turns music and dance into an interactive experience for everyone to enjoy. Where our project breaks down is the ability to play any music you want, and the game itself will generate a dance track for you to dance with. Instead of a pre-programmed list of songs available to you, Rhythm Stomper will generate a dance track based upon the music you play as listened through a microphone. It'll listen to the song through the microphone, analyze the beat, and create a dance track. The dance pad, painted in black and orange in honor of OSU, is comprised of MDF, acrylic sheets, and steel brackets. Inside of the dance pad are 4 star LEDs of red, green, blue that are used during gameplay, and aluminum copper sheet metal plates that are combined to make touch plate sensors. The second component, the enclosure, contains all the internal components of the project itself. Inside are the microcontroller, the screen, the LCD, the fan to prevent overheating, the power circuitry, the microphone, and the filtering system used to analyze dance tracks.
This is the top-level block diagram for our project. The whole project is powered by the power block, which requires a wall wart or 6 AA batteries. The microcontroller we used was an Atmega 128 and is the heart of our project and controls all extremities and distributes the power to all other blocks. The software block represents the C code programmed into the microcontroller. The user interface is the liquid crystal display mounted to the surface of the enclosure and displays feedback to the user. The music detection block registers the external sound, then filters and amplifies it before sending a signal to the Atmega 128. The dance pad is how the user interacts with the game. The lighting block is the 4 red, green, blue light-emitting diodes or LEDs located in the 4 arrow buttons of the dance pad, which tell the user when and what arrows to step on when playing the game. The cooling system is a simple circuit that turns on a fan when the temperature inside the enclosure gets too hot. And finally, the enclosure houses all the electronics that are not inside the dance pad. The enclosure is made from 14-gauge cold-rolled steel and was given to us by our sponsor, Protocase.
Now we'll look at the music detection block in more detail. This block uses a standard electret microphone to detect the music signal. It is powered by 5 volts from the microcontroller. Resistor R1 matches the impedance of the microphone, giving the signal maximum room to swing. Capacitor C1 is a DC blocking capacitor, which allows only the analog portion of the signal to pass. R2 and C2 form a low-pass filter, which ensures that only the bass in the music is detected. The values of R2 and C2 were initially calculated so that 160 Hz was the cutoff frequency. However, initial experiments resulted in the circuit not being sensitive enough to bass, so the value of R2 was raised until the cutoff frequency was 33 Hz. Next, the signal goes through the LM386 power amplifier chip, which has an adjustable gain of 20 to 200. We chose a gain of 200 to end up with a peak-to-peak swing of about 2 volts. Capacitor C3 is in place to set the gain to 200 by bypassing the internal resistor. Capacitor C4 isolates the signal from power supply noise, providing stability. The amplified signal is then sent to the analog to digital converter on the microcontroller.
This is the power circuit diagram for the project enclosure. On the left is the 120 volt AC to 12 volt DC wall wart, plugged directly into a standard DC power plug affixed to the inside of the enclosure itself. The power must then pass through a 1 amp slow blow fuse before entering into the power charging board. This board, designed by the Oregon State Tech Bots, works as a splitter between the battery pack and the power supplied by the wall wart. When plugged into the wall, the charging board recharges the battery pack using the supplied voltage and also powers the game. When the wall wart is not plugged in, the battery pack instead supplies power to the charging board. The on-off switch, located between the charging board and the microcontroller, is the master on-off toggle that determines when current is to flow to the microcontroller. Having the power switch in this location allows the batteries to be charged without the game running at the same time. When the power switch is on, the power is then supplied to the microcontroller through the charging board, and then on to the external components run through the microcontroller.
This is the cooling circuit for the enclosure. It is supplied 5 volts from the microcontroller. R2 in the potentiometer labeled PON create a reference voltage by making a voltage divider. R1 in the thermoresistor create a varying voltage divider that depends on the temperature inside the enclosure. When the thermoresistor heats up, its resistance goes up and the voltage across it increases. Once the voltage across the thermoresistor is higher than the reference voltage across the potentiometer, the operational amplifier, or op-amp, labeled U2, will output 5 volts. This will turn on the bipolar junction transistor, or BJT, by applying voltage to the BJT's base pin. This will apply voltage to the fan, turning it on. The capacitor C1 is used to lower the noise.
This is the main menu of the user interface. You have 3 options. The first is New Game, Difficulty Select, and Test Dance Pad, and I'll show you all 3 of them. So in Test Dance Pad mode, if you go into it, you can try all the arrows and make sure they work. So here we have up working, right, down, and left. And also when you step on them, the lights on the dance pad light up. So you can see they're all lit up. You step on them, they turn off. Okay. And then you press stop to get out of it. Next menu is difficulty select. You have easy, which is 3 blue flashes and then green. Medium, which is 2 blue flashes and then green. Hard, which is 2 blue flashes and you can have 2 arrows at once. And expert, which is 1 blue flash and you can have 2 arrows at once. So I'll put it on hard. And then you go into game mode. It'll give you a short tutorial. And you press right to keep going. And this is where you start the music and play the game. So here we go. Press stop to quit, and then you can see your score on the user interface. I got 7 out of 10, and press right to go back to the main menu. And this concludes the project demonstration.
So, helpful hints. First one is, make sure you know what materials you're using and how they're going to affect your project. MDF is really heavy and never solder to aluminum.
When ordering online, consolidate all your orders to one single order from a single location. When ordering from multiple locations, shipping and handling costs can really add up, and it can put your project over budget very easily.
And finally, plan to finish your work well ahead of deadlines so you have plenty of time to fix any problems that might arise.